Last week we got our hero knight working, but now it's time for the forces of evil to have their day. Hey, and welcome back to the Chromeworks studio in beautiful Ottawa, Canada. I'm Andrew Tomec, your technology teacher, back with another great coding lesson for you this week. So we are on part 2 of our fabulous new Joust game. Very excited by this project. It's put together by my co-op student, Liam Desrosiers, with a little bit of help from my son, coding guru Jeffrey Tomec, and we're just thrilled to bring this project to you. It's one of my favorite old arcade games from the 80s, so and quite nicely done as well. So let's have a look at what got done last week. So I'm looking at the part 1 catch-up file. I've just done a save as because I'm going to be adding part 2 to it. But this is all the code that we added last week. And basically we got our bird flying around in the air. We got his physics set up so that he's flying up and down around the screens. He's bouncing off of walls and flying quite nicely through this very crowded environment with little platforms all over the place for us to bump into. So that's all working quite nicely. He walks when he's on the ground, stops quite awkwardly when he's coming up to an edge, and then we can flap him through the air. This game reminds me a little bit of Flappy Bird, and I wouldn't be surprised if the creators of Flappy Bird probably took a little bit of inspiration from the flying mechanics in this game. Anyway, so today we're going to be building the enemy knights who are going to be fighting us on this field of battle, and so that will be our next mission. There's quite a bit of code here again. I warned you guys at the start of part 1 this is a very complex project, and it's going to take us, it looks like right now, maybe 4 weeks to put this together. So we're on part 2, and right now we're just going to be looking at enemy movement and get our enemies up and running by the end of this session here. And then we can look at some of the other more mechanics related to spawning and things like that next time. We might get done next time. I need to take another look at the code anyway. So I'm going to keep my options open here. So let's get over to the enemy character and we will start coding him. So let's just start by initializing some variables. I'm going to get a green flag out here to start, to signal the start of our game, and we're just going to set some variables. So we have a velocity for the eggs. So when we kill an enemy knight, it will spawn an egg basically, and that egg will drop to the ground. And if we don't catch it soon enough, it will hatch and form a new bad guy. So that's a good incentive to chase after these guys as their eggs are flying across the screen. Alright, so we need to track the velocity of the eggs using 2 different variables. So let's get those out and initialize them right now. As is always the case, I've got all my variables all set up here already for you. So there is a catch-up file. You'll find the location of that inside the description for this video file, and that will get you caught up with where you are. So I would prefer you went back to part 1 and built that and then just added from there. But if you really want to jump in at part 2, just grab the catch-up file, and that will have all the code that we completed last week. Anyway, so let's go ahead and set our variables. We will set egg y velocity and egg x velocity. So that's just describing how fast they're moving up and down across the screen, and left and right, of course. All right, we've got another variable here called enemy clones. Set enemy clones to 0. So that's just keeping track of how many bad guys there are on the screen. And we want to determine whether our bad guys are eggs or not. So we have another variable here called isEgg. And it's set to 0 right now. And we can hide these guys. So let's go ahead and go to our looks commands and tell them to hide. The master guy, of course, isn't going to be visible, and the clones will be visible. Okay, so let's grab a forever down here, and we can start with the actual code for spawning these guys forever. All right, so we're waiting here for the variable called start game to equal on, and that will be the signal that we're out of our start screen and we're into actually coding the game. So let's grab an equal sign, and we'll grab an if statement under our control blocks. If equals on, and on the left side there we want that start game. So we'll go to our variables, grab a bubble here that says start game, and pop that into the hole. There we go. If start game equals on, then we're going to wait 5 seconds. So this is going to give you enough time to run around the screen before the guys start spawning. Generally speaking, you want to go to the top where it's a lot safer. Of course, stuff can only kill you if it's above you. So the high ground. I have the high ground, Anakin. All right, wait 5 seconds. And then we're going to change the wave number. So right now the wave number is, I guess we initialized it in a different spot. So we'll change the wave number by 1. Let's go ahead and do that. So we'll go to our variables. We'll go change a variable, change, and that's still inside. So yeah, right underneath the 5 seconds here, we're going to go change wave by 1. So we start on wave 0 and immediately get into wave 1. So there's no actual wave 0. It'll just immediately set itself to wave 1. And now we're going to spawn a number of bad guys that's roughly equal to the number of waves plus 2. Now there's some other variables that affect the spawning of the guys, so it's a little bit more complicated than that. I'll show you in a second. So let's go repeat wave plus 2. So whatever the wave, so in the first wave, we should theoretically be getting 3 bad guys, right? So where's our wave? There it is, wave plus 2. That will give us 2 bad guys in the first wave. And inside there, we're going to put all the code for spawning enemies. It's quite a bit of code, so we're going to pop that into a custom block. Let's go make our custom blocks, make a block, and we're just going to call this one enemy spawn. And it doesn't need anything fancy in it, so we'll just go ahead and drop that block in there. And we can go, we're going to go in a second and define what enemy spawn looks like. But let's just finish up here because we just got a couple more blocks to do here. So after this little repeat loop where it's spawning enemies, we're just going to have it wait until they're all dead. So let's go to our control blocks. Grab a wait until. So that is going to be right underneath the enemy spawn, right here, inside the second if statement. Sorry, inside the if statement and inside the forever. Wait until enemy clones are equal to 0. So what's going to happen here? Let me fill this in for a second. animation, rather than just appearing in that spot, they're going to kind of grow out of the platform area here and go and kind of grow up from there. So that process takes 0.7 seconds. So once that's done, that's when we're going to have our knights appear and start moving across the screen. We're going to send the first guy to his first spawning position, which is go to -10x and -105. So I'll just show you where that is on the screen. So if I just make my enemy bad guy visible, where is the fellow? Anyway, as soon as I click on the location block, this is where he appears. So this is the spot for the first guy to appear in. That's not quite right, is it? Let's tell him to go a little bit to the left. I'm going to say -20 instead, maybe. See if that looks better. Yeah, that looks closer to the middle of the spawn area, or maybe even what, 10 more. I think we did some tweaking to the map while we were setting these up so people aren't in the right spot. Okay, that's looking good. He's a little bit big, but we're going to shrink him later on in the code, I'm pretty sure. All right, so we can hide that guy again, and we'll put the starting location there. Actually, we're going to be doing this again a couple of times. Okay, so we're just going to duplicate this whole big chunk of code in this if statement, and we're just going to make a minor change to it. So if random equals 2, we're going to do the same thing, spawn, except we're going to spawn in a new area. We'll spawn him at the left side of the screen. So we'll just type in spawn left here in our event. And our start location, of course, will also be different. And that's going to be -197 and 18. Let's just have a look and confirm that that's the right spot as well. Let's leave our guy visible. He is visible. So yeah, that looks like a fairly good spawn there. He's a little bit too high though, eh? Let's move him down to the ground. So maybe 10. -197, 10. That is looking perfect now. There we go. He's right on the ground. Okay. And we need to do it one more time. Sorry, I put a 3 there instead of 2. That's if our random number is 2. Let's duplicate, and then we'll say if our random number is 3. Let's spawn right. Let's type that in. Spawn right. Okay. And again, we need a new location, so let's try that one out. We're going to say go to an x of 116 and a y of 28. And let's see how well that character goes into that spot. Whoa, that is not the right location either. So here's another thing we can do. We can just drag the guy over to the spot here and see what our computer's telling us. It's actually 138.11. As I said, we made some changes to the map after we coded that, and that's why these things aren't quite fitting properly. Okay, beautiful. So that's looking good. We're not going to be able to see these guys really do much of anything right now, though yeah, they're not even going to appear because they're hidden at the start. So, okay. Now, let's, so once we're done figuring out where our guys are going to spawn and telling them to go to that spot, then, so we're going to send our clone making guy to that spot, and then he's going to go ahead and create a clone of himself. So let's go do that under the bottom of our control blocks, create a clone of myself. And now, let's change that variable, enemy clones. We'll go to our variables, change enemy clones by 1. And so that'll tally up that we have one more bad guy on the screen here. We're going to start them moving up. So as soon as they're created, they're going to fly up in the air, and then the AI will take over after that. So their start velocity set y velocity, y vel. It's actually y vel, yes. There was another variable called x velocity, and I believe that's used somewhere else, probably in our main character, if I remember correctly. Okay, so far so good, and we're just gonna wait 1 second here before their AI takes over. So let's go ahead and go control, wait 1 second, and now we're ready to start coding the next chunk of that. Okay, so far so good. This is one of these projects that's a little bit frustrating for kids to code, I would imagine, because it's hard to really see what's going on. We're adding so much code here and nothing actually ends up showing up on the screen. We're not going to see bad guys appear for a little bit here. So we're going to have to just keep plugging through here, trusting that this is going to work until finally these guys start spawning and flying around. It'll happen a little faster than it did for our main character, where it was the last 5 minutes before we actually got our guy moving on the screen. And I'm sure that was frustrating for you guys, but we'll try and get our bad guys up and moving as soon as we can here. Let's go have a look at where we are in the code right now. All right, so next thing we're going to need to do is tell our guys to, this is going to be the main control block for our bad guys. So we're going to do a when I start as a clone, which is at the bottom of our control blocks here. And we're going to get our guys into a loop where they're basically just checking whether they're colliding with a bad guy and basically flying around the screen. So we've got a couple of sub-branches that we're going to get into that control those different functions, but this is the main block of code that's going to be doing that. Okay, first thing we want to do is set our rotation style to left, right. We'll go to our motion blocks, set rotation style left, right, and that means that if our guys get tilted in a different direction, let's say a 45-degree angle, they'll move in that direction without actually tilting their body. So they'll actually move like this, staying vertical the whole time. Okay, we're going to show our guys. They were hiding before, so let's go looks, show, and we're going to shrink our guys down to 20% because that's actually the right size for them. That seems a little small. 2.8. So that will just slowly bleed the speed off. Any number times the decimal is going to get smaller every time it comes along here. Okay, now we're going to do something that's going to be reminiscent to you guys if you were looking at last week's code. We're going to say, we're going to start looking at the absolute value of our x velocity. So let's go if, I'm going to grab an absolute value. I'm going to explain this one more time for you guys who weren't listening last week. But first I need an absolute value is less than 3. So what we basically want to know is if our absolute value of x velocity, I got to grab an x velocity. We're basically saying if our speed is less than 3 or if it's greater than -3, right? The absolute value of the speed is basically, if it's a negative number, it's going to turn it back to a positive number. So we're just really checking to see if we're moving at a speed of less than 3. But if our speed is -3, we just want to treat it as if it was 3. We're saying, so it'll still be true if I'm at a speed of -3 or -2.8, or I'm at a speed of 2.8, it'll still, the code will treat it the same way here, because we're looking at the number stripped of its minus sign. That's what absolute value is all about. So if that's true, we're going to set a new x velocity, set x vel, and we're going to set it basically to 3, but again, it has to be the same speed that it was before. So if it was -3, we're going to set it to -3, and if it's +3 or less than +3, we're going to set it to +3. And again, we're going to do some clever stuff with absolute value here so that we can do it all in one block of code. There are probably easier, less complicated ways to do this, but I'm showing you a really MLG way to do this where it's all compressed into one block of code here instead of having to use an if statement to figure out whether he's moving left or right. So anyway, this is a little bit complicated here, but we're going to grab an absolute value sign again. Just follow with me as I construct this. It's at the bottom of our green blocks. We're going to put that inside of a divided by on the right. So grab the divided by, put the absolute value on the right of that. And then both these blocks, which you can grab by the divided, they're going to go into a multiplication block, a star. So let's put it into the left side of that. Okay, we'll fill in all the numbers here and then I'll explain it. So it's on the left, we need our x velocity. And we need our x velocity here again. I'm just going to, x vel. I just messed that up badly. Okay, I'll grab a new x vel so I don't do that again. Times 3. Okay. So let's drop all of this code into the set x velocity. And so what we're doing here is we're calculating our x velocity divided by the absolute value of itself. What that will basically do is give you a number, end up with a number that's 1 or -1. After all of this calculation, all we're going to end up with is a number of 1 and -1, and I can kind of show you the math that goes behind that. But I think, so if I was moving at a speed of 2 over absolute value of 2 is 2. 2 over 2 is 1 times 3 is 3. So we're moving at a speed of 3. If our x velocity is -1 over the absolute value of -1 is 1. So -1 over 1 is equal to -1. -1 times 3 is -3. So that means set our velocity to -3. So you see we got a 3 or a -3 out of this, depending on whether we were moving in a positive direction or a negative direction. So a really elegant piece of code here that does something that could be done with an if statement, but we like doing things fancy here at Chromeworks. Okay, let's go change our y velocity. So now we're going to figure out our up and down movement here. Y velocity, change it by -0.25, and that's our gravity pulling us down. So our guys are basically being tugged downward, and they'll keep going downward until there's an upward impulse. Now, we're actually going to start moving our guys now. So let's go change our X and change our Y. So we'll go change X and change Y. We're going to change our X by, not surprisingly, by our X velocity, X vel. And we're going to change our Y by Y vel. Okay, and that'll get us actually moving. Let's see if anything's happening in our game right now. Let's click the green flag. And wait a couple of seconds for our guys to spawn. There we go. And they're being created now. Now we don't see them spawning, and they all came out of the same spawn area as well. I wonder if that's just pure chance or if something's not right in the code here. Let's wait another 5 seconds here for these guys to start. That guy started there. They're always coming out of the same spawner here, eh? That's a bit of a puzzle. Let's go have a look at our enemy spawn code again. We're picking a random number from 1 to 4. Oh, we haven't told them where to spawn because we haven't actually figured out these broadcasts yet. That's something that we're going to... Oh, yeah, no, they should actually be going to their location. I'm a little bit puzzled by that. I'm going to look into that and I'll be right back. Alright, I wonder if you guys caught my error, because I made a little booger here while I was coding this. Under define enemy spawn, I told you guys to put set random here, and for some reason I slided it over to points instead of random. So we're just going to go down to the next one. That was just a little slip of the fingers there, but let's test this out again. And now these guys should be coming from truly random spots. So... wait 5 seconds. There's our first guy coming from that spot. Second guy coming from that spot. Beautiful. And our third guy. Oh, we're only getting 2 guys. As I said, sometimes it'll be 1 less than the maximum for that particular round. Okay, that's working beautifully. While our guys are spawning here, we can do a little bit of code here to make them wrap around the screen. And let's find that little block of code right now. We might as well just enter that just to get them moving properly across the screen. So we're going to do another when I started the clone here. I'll just drop it off to the side. Control when I started the clone. We're going to grab a forever here, and we're just going to be checking to see if they're at the edge of the screen and then moving them off of it if necessary. So we're going to go if X position is less than minus 240. So let's grab a less than sign. Grab our X position, which is a blue block under our motion blocks. Our Black Knight's X position is less than minus 240. Then we're going to set our X to 240, which will drop him around the other side of the screen, 240. And we're going to do the opposite in the other direction. So let's go duplicate this code. We're going to want to swap out this less than sign for a greater than sign. So if our X position is greater than 240, then we'll make our X position minus 240. And that, boys and girls, is how you do screen wrapping. Let's show you that again. We'll wait our 5 seconds for our bad guys to appear. There's our first guy, and you'll see when he goes off the edge of the screen. Whoa, they're not teleporting. What have I done wrong? If X position, that should be wrapping them. That is peculiar. Once again, I'm in trouble here. Let's have a look. All right, again, that was a fairly simple fix. It was, so I was a little puzzled by why these guys weren't wrapping around the screen, and so I wanted to, after a bit of thinking about this, I really wanted to know what the actual X coordinates were to find out why it wasn't actually doing what I was telling them to do here. Now, it's difficult to find the X location of a clone, if you're looking at the main object, you can always look up here and see what its X and its Y values are, but the clones don't have a panel like this to tell you where they currently are. So the best solution for troubleshooting these things is to insert a block that actually makes them tell you what their location is. I'm going to grab a say block, which would normally make my guys say hello, or whatever I type in there, and I'm going to tell them to just constantly say their X position. And so little voice balloons are going to appear around these guys, telling us what their X and their X coordinates are. Watch this, here they come. So our left guy goes and hits at minus 240. Yeah, and you can see the same thing's going to happen at the right. They end up at minus 240 or 240. So the problem is they never actually exceed that number. They never get greater than. They're equal to that number rather than that. Now, we don't want to say equals to here because every once in a while they might be off by 1 or so depending on where they start from. So let's just make this threshold a little lower here. Let's say minus 239. We're actually going to change all of these numbers. So let's change this to 239. We'll call this 239, and we'll call this minus 239. And that way, when they're just 1 pixel away from the edge, they will be transported to the other side, and just 1 pixel away from that. So let me show you what that looks like now. Our guys will spawn one more time. And the guys who are moving to the right will just go through the wall. Oh, good, we've got guys moving in both directions now. So you can see that this is in fact working in both directions perfectly. Awesome. Okay, let's get rid of that say block while we're at it. We don't want our guys reporting their X position because other than troubleshooting, who really cares? There we go. If. All right. So we're ready to move on now. We're in pretty good shape. So we're in the handle physics area here. Let me just find that in my main code. All right, so we've actually started moving here. The next chunks of code in this handle physics all have to do with basically bumping into these barriers sideways. So we already created some code here. No, actually just bumping into these barriers completely in any direction. So what we're going to have to do is determine whether we're moving up or moving down and bounce off of them accordingly. So we're going to grab a big if statement here, and I just want to double check if it's not an if else. There's an if else inside the if. Okay, I'll try and remember that. So let's go to our control blocks. We'll grab a big if statement, and we're going to say if I'm touching the stage. Now remember, the stage is the area with the platforms here. So they're going to be flying through between these platforms. But if they hit a platform and in any section here, that's going to be equivalent to hitting the stage, and then they'll be able to follow their AI to determine what to do next. So let's go back to our enemies here. We'll say if touching stage. Let's go to our sensing blocks, touching. I'm going to grab touching mouse pointer and change it to touching stage. There we go. If I'm touching the stage. Okay, so the object here is to figure out whether our bad guys are moving up or moving down so that they can bounce appropriately. Of course, if they're hitting something with their head, they'll bounce down. If they hit it from the top, if they hit the top of a platform, they'll bounce up. So we're going to do an if-else statement in here that's going to determine which side of a platform basically that we're hitting and which direction to bounce in. So let's grab an if-else from the control blocks. All right, and we're going to say if our y velocity is greater than 0, which of course will mean that we're moving up. So let's grab a bubble that says y velocity, y vel. Here it is. If our y vel is greater than 0, then what's going to happen? We're basically going to start moving. So if we're moving up and we hit something, we're going to start slowly moving down 1 pixel at a time until we're no longer touching the stage or the edge of the top edge of the screen as well, since that's another thing we can bump into here. So let's go grab a repeat until block from our control panel here, control blocks, repeat until. We're going to say repeat until, and we need two things to check here. So we'll grab an or statement from our green blocks. And we want to say we're not touching. So let's say not touching stage, which is a sensing block, a blue block. Not touching stage. So if we're not touching the stage or touching the edge of the screen, then we're going to change our y by -1. And just going to keep repeating that until we're no longer checking, and then we'll break out of this loop. Let's go -1 here. All right. Once we bounced off, we're going to start moving in a downward direction. So we're going to set our y velocity. Let's go to our variables. And we're just going to start ourselves moving in a downward direction. So we're going to set, so right underneath this repeat loop, we're going to set y vel to -1. And that will get them moving down. All right. So that covers the moving down. Let's do the same thing for the opposite situation. So I'm going to grab this repeat until block and everything below it and duplicate it. We're going to need to make some changes, but we can shove this into the else. And we're going to say the same repeat until, not touching stage or touching edge. But in this case, we're moving in the opposite direction. So we have to bounce in the opposite direction, which is 1. And we're going to set our y vel not to -1, but to 3.5, because we're going to bounce up quite a bit faster than we bounce down. And we're trying to fight the force of gravity here too, you'll recall. Okay. The other thing we want to do for flying upwards, so as soon as we start moving upwards, we want our guys to be flapping their wings when they're moving up. When they're falling, they can be gliding, but when they're moving up, they have to flap their wings. So let's grab this set animation block. We actually want to put it in twice, just because this is not a looping animation. We need a way to reset itself so that it'll restart the flapping animation. This is a little bit complicated, but basically with Jeffrey's animation system here, we're not able to, the animation won't restart itself if it's in the middle of an animation cycle doing a different animation, and so we would have to wait till the end. So this will kind of, so if we set blank in the first one, it will automatically remove all the existing animation, and then we can set a new animation down below. So I'm going to say set animation blank, delay of 0.05, which is the same one we're going to be using below. So let's type that in there, 0.05. And then our animation name is going to be flying with a capital F. Remember, this is case sensitive and it has to be spelled exactly the way that it's spelled in our costume, which is with a capital F, as you can see there. All right. Good. Let's go back to our code. Oh, I'm in the wrong character, or I'm just in the wrong spot here. So where did I go? Handle physics. There we go. And the last little bit of this block is point in direction x velocity. So once we get out of all these loops, we're just going to tell our character to point in whatever direction their x velocity is taking them, which is going to be basically a speed of 1, 2, or 3, or -1, -2, -3. So let's go point in direction x vel. And we'll drop that x vel into there. Okay, cross your fingers. I think we can test this now. The flying's not going to be perfect. There's one more little bit of flying code we have to add here that's going to give these guys a little bit of artificial intelligence so they move around the screen following you. But for now, this should at least temporarily work. So let's give her a try and see what happens here. Wait for our bad guys to spawn. There they go. And you can see they're kind of bouncing around the screen, which is basically what we want to have happening here. Now there's still an issue with them not resetting their costumes, and I'm going to look into that right now. Okay, I figured out my flap situation, and it had to do with the animation system here. I originally had a green flag here, which is the way it's set up for your main character. But of course we're dealing with clones here, so I had to substitute in when I started the clone here. Otherwise our characters are just going to ignore all of these animation commands. Let's just do a quick demo here, just to show you that this is working in fact. So we'll wait for our bad guys to spawn. Here they come, and you'll see that every time they launch themselves off the ground, they flap their wings once when they're moving upward. Perfect. Okay, so you'll notice that their movement is a little bit clunky. They tend to spawn after they spawn, they tend to move in a downward direction. So we're going to create some new code here that makes them go up, but not all the time, just depending on where our character is. And this is where the little bit of artificial intelligence comes in here. They're simply going to be drifting downwards generally through this thing unless we're above them, in which case they're going to make some random choices based on where I am that is going to make them occasionally want to go upwards and track upwards to where I am. So we're going to install that code right now, and things are going to look much smoother at the end of that. So we're going to start with another when I started the clone. Let's go ahead and grab that from the bottom of our control blocks, when I started the clone. The first thing we want to do is, in case these guys are an egg when they're first formed, after they die the first time, they're going to turn into an egg, and then they're going to, once they hatch from their egg status, they're going to resume their status as an ordinary bad guy. So we can't have them flying and moving around when they're an egg. So we're going to have them at the beginning here wait until they're not an egg. So let's go ahead and say wait until is egg is equal to 0. So we have that variable tracking whether they're an egg or not. So let's go grab that and plop that into this position. Is egg is equal to 0. All right. So now we can do a forever loop once we get past that hurdle, where we're checking, we're comparing our y coordinates with the y coordinates of the enemy at this point. Okay, first of all, we want to we don't want this happening all the time. We just need a little bit of a delay here, so we're going to grab a wait, and we're going to have it wait between a random range of very small numbers here. So pick random 0.1 to 0.2. So this will make it so they're not constantly updating their motion, but just occasionally, a few times a second. All right. Now we're going to pick a random number here again. So let's go set our random number variable. Set random. Set random to. Now we got some very complicated math here, which I'm going to try to explain to you. It's not complicated, it's just long more than anything. There's just lots and lots of math in here. So we're going to start with a minus sign. So let's just build this, and again I'll explain it when we're done. So we start with a minus sign. On the left side of the minus sign, we're going to put another minus sign. And on the left side of that, we're going to put a plus sign. See, this is simple math, but just a lot of it. And on the left side of that, we're going to put a pick random. There we go. So we're looking like this now, a pick random, and then a plus with a blank number, and then two minuses with blank numbers after them. Okay, so we're going to pick random, a random number between minus 200 and 200. Plus, now we need to know what the y position of the main character is. We're not in the main character here, so we have to go looking for what that is, and we're going to use our reporter block, that powerful block we use from time to time in our sensing blocks. It's right over here. I'm going to change this from stage to main character, and then I'm going to change the attribute I'm looking for to a y position. There we go. So this will always report back what my current y position is of my character. Right now it's minus 109, but you'll see if I drag it around the screen and go back here again, that now my number is 141. So it's keeping track of the movement of this character here. Let's drop that into that middle position. And then we need to put Y position down, which is under our motion block. So we need to put that in twice. Once here and once here. Okay, so we're picking a random number between minus 200 and 200. Let's say it's 100, for example, plus the Y position of our main character. So let's say our main character is at a Y position of around 100. Well, that would be up here, actually. All right. So let's say the number we pick is 100. Our Y position is 100, so that's 200 minus our Y position. So let's say we're below him, so at a position of 0, so we'll go minus 0. So we're at 200 minus 0 minus 0 again. And so the final number we get is 200. And we're really underneath here, we're just checking to see whether it's a positive or a negative number. So because that's a positive number, our character is going to move up. And if we rolled a little bit differently, rolled a minus 200, then it would end up being 0, and we wouldn't end up going up. So the farther away we are from our enemy, the more likely we are going to be to want to move up. And that's going to increase on a sliding scale as we get farther and farther away. And the closer we get to our enemy, the less likely he's going to be to want to change directions. But there's lots of random in here, so he's going to want to change his position every once in a while anyway. Okay, so I'm going to grab this whole thing by the right-hand side here so that it doesn't fall apart, and I'm going to plop that all into set random here. Okay, so this is all looking good. And now we're just going to check and see if that random number is positive. So let's go grab an if statement. And we're going to say if random is greater than 0. I'll put a 0 in there, and let's go looking for a random, which is a bubble in our variables here. There we go. All right, so if that's true, we're going to set our Y velocity a little bit higher. So we'll go to our Y vel. Oh, we need to set, sorry, yeah, so we need to set Y vel to 2.5, which is going to send him flying upwards a little bit. And now we need to, since we're moving upwards, we need to be flapping our wings. So we're just going to grab those same 2 blocks that we used before. Let me duplicate them from here. And we'll drag them down into here. So tell him again to flap. Okay, so you'll see our guys will no longer be trending downwards because they'll always be trying, depending on our height, they'll be trying to get up higher. Let's play the game a little and see what that looks like. I'll fly up to a higher location. There we go. And you can see these guys are trying to get up to where I am. There, that guy's up on my level now. And now that I move below, he pounces down on top of me. I can't die yet because we don't have collisions. Let's go down to the bottom and see if they follow me down there. And you can see that it takes them a while, but eventually they do start to migrate down there. So this is looking very much like the original Joust game. This congratulations to Liam, and I think some help from Jeffrey as well for figuring this AI out. It's a fairly simple system, but it's working quite nicely. Let's go up to the top again and show you one more time how they will follow me up to the top of the screen and try to get up as high as they can to try and get me. Whoa, I'm whizzing through here. I don't know if there's any speed limit on these guys, and then they come back down again, chasing, leading them a merry chase. All right, so this is looking really good now. I'm actually really happy with our progress here. We have a little bit more code for collisions, so since we're doing okay for time, I'm going to add the last little block of, well, this is not the last block, there's more to do, but the last bit that will allow us to have collisions with each other in here. So let's go back to our game here. I'm going to grab this custom block that we created way earlier called collision handling. And let's just code that, and that will be the last thing that we do here today. All right, so if touching the main character, and that is one gigantic if statement, so let's drop that in there. We'll go to control, we'll go if touching main character, okay, so this is if we smack into the guy. So we're going to have to do a determination on whether our length is higher than the other one. So we're going to compare our y coordinates to the y coordinates of our main character, and depending on whether we're above or below or kind of equal, we'll do three different things, right? If we're above, we win. If we're below, we lose. And if we're kind of the same, then we're going to bounce off of each other. So we got to do some code here to determine that. Okay, so let's set our xvel, which is our enemy character's horizontal speed, xvel. And we're going to do a little bit of math here comparing the bad guy's position to the main character's position. So it's going to be a multiplication symbol, little star here. Oh, that I grabbed a plus by accident, sorry. So here's a star, and on the left-hand side of that, we'll need a subtraction and a minus sign. Just like that, let's drop that all into the variable. And so we're going to say our x position, which we'll find under the blue block, motion blocks, our x position minus the x position of the main character. Let's go grab another reporter block. We'll change it to say main character x position. There we go. So the bad guy position minus the main character's position times 0.5. So these guys are going to be fairly close to each other when they hit. It's going to be a fairly small number, but we're going to make it even smaller by multiplying it by 0.5. We're going to do the same thing with the enemy speed. We're going to have him bounce back and change his speed as well, but we're going to do it by a different multiple. So remember, the main character's x velocity wasn't xvel. The variable for that was x velocity. So we've used the two slightly different named variables here in two different places, one for the character and one for the bad guys. Okay, and we're going to do kind of the same structure here. So I'm going to just, well, we've already duplicated this. What we need to do is switch the order of these. So it's going to be x position of main character minus x position. We'll switch that like that. And the multiplier here is going to be 0.2. And that will get them bouncing off of each other. Let's give that a try and see if that works. So I'm going to purposely crash myself into these guys. No one's going to die or anything yet, of course. But I'm just going to purposely hit these guys. There we go. And we're bouncing off of each other quite nicely. Whoa. We got something really cool going here already. It didn't take much code to make that happen. Whoa, and that blasted me right off the screen here. Hey, this is really fun. So this took a long time to get going, but now that it's working, you can see that we got a nice little game going here. So impressive. Okay, so now we just need to look at our life and death conditions here, which all, as I said, have to do with our y position compared to our enemy. So, we also need at the end of this to change our y velocity by 2, and that will push us upwards when this happens. So let's go to our variables. We'll go change. So inside this loop here, we're going to go change y velocity, which is the velocity of our player, by 2. And let's see what that does. I think that will push us upwards a little bit when our bad guys appear. Yeah, so we tend to bounce up just a little bit when we're away from when we bounce into these guys. Let me try hitting one from below. Yeah, so when we're below, we kind of clip right through them and get thrown upwards quite a bit. All right, just a little bit of housekeeping there. All right, now right below there, we're going to add a couple of if-else statements nested inside each other. And let's start with the first one. We'll grab an if-else statement. So now we're comparing our position to the y position. We're going to need this absolute value again. So let's set this up down below and we'll plunk it in there in a second. So we need to start with a greater than sign. And on the left side of that, we're going to need an absolute value. Grab that from the very bottom of our green blocks. And inside the bubble here, we're going to put the y position of the main character. Let me just duplicate this reporter block and we'll pop it in there and change it to y position. So the absolute value of the y position of the main character is greater than 8. Which means, oh, minus, sorry, I have missed a whole section here because we're comparing it. Absolute value of, yeah, let's get rid of this y position. We'll put a minus sign into this spot here. So y position of main character minus the bad guy's y position. There we go. So we're going to look at the y position of the main character. Let's say it's 100. Sorry, the bad guy, minus 100. And let's say this guy, our own character's at 90. So it'll be 100 minus 90. And if it was a negative number, we would convert that into a positive number using this absolute value, but that's not important right now. So so now the distance is 10. If it's greater than 8, that means... So this code here is basically comparing the positions of the two characters, and if it's greater than 8, which means that their distance is far enough from each other, then we're going to trigger a death event for one of our characters. Which one depends on who's the higher one, but so we're basically going to do, in this if-else statement here, we're going to see whether somebody dies in this condition, and if not, we're going to have them bounce off each other in this condition. And then inside here, we're going to put another if-else statement that is checking to see who's the higher one. So let's go grab another if-else statement and pop it in there. So if the distance is enough, we're going to check and see who is the higher one. And we're going to do that with another equation here with a greater than sign. So let's go grab a greater than sign. And we're going to say if our y position, the bad guy's y position, is greater than the y position of the main character. Let's just duplicate this one and, click the wrong thing there. And drop that in there. So if our y position is greater, that means the bad guy is dead, or the good guy is dead, sorry. And we need to make sure this doesn't happen if our character is spawning, which means he's invisible or after he's dead and before he's respawned. So we're going to just add another check here to make sure our character is in fact able to be injured. So we'll grab an if statement here. If, we already have the if statement, and if invisible is equal to 0, which means he's not invisible. And with our invisible, there we go. If invisible is equal to 0, then we're going to start a sound, and that's our Joust death sound. Joust death, and I'll play that for you, so you can hear what that sounds like. And we're going to broadcast a message, which is going to say lost life. And that will do, let's create a new message here. And that will change the number of lives we have down here in the readout bar, and it'll trigger a respawn of our character in a new location. And not all that code is in place right now, so we'll have to add it later. All right, so if invisible, good. Now we're into the else statement, which is bad guys die, right? So we're going to say else. We're going to play that sound death again, so let's just duplicate that. We don't need the broadcast. We do need to broadcast enemy kill here, but we don't need it yet. Let me just set that up to enemy kill. But we're going to add that in a second. So we're going to turn our bad guy to an egg. So let's go set a variable. Let's go to our variables. We're going to set isEgg to 1. That will later on in our code that we add next week, that will turn our guy to an egg. We're going to change our points here, of course. Let's go change points. We're going to give ourselves 100 points for killing a bad guy. You can, of course, change that if you like. We're going to change our Y. So we're going to get knocked down a little bit. Change Y by -20. We're going to create a clone of ourselves, and that's what's going to turn into the... so we're going to create a new clone of ourselves, that's the egg, and it's going to appear in exactly the same location where we were. So let's go to Control, create a clone of myself, and then our new guy, our newly spawned guy, will follow his new instructions for what to do with an egg. But meanwhile, we can kill this guy off. So we're going to broadcast enemy kill, which will trigger some other stuff elsewhere in the game. And then we're going to delete this clone. So that will get rid of this guy, but he will respawn as a new fellow if we don't catch him. And the last thing is we're going to start a sound bounce here. So if our guys aren't far enough apart from each other, they're just going to bounce off each other. Or the code is already making them bounce off each other. So all we have to do here is play a sound to show that they bounced off each other. So let's start a sound called bounce. You can hear what that sounds like. So not much will have changed in the code here because we haven't actually set up the events for these guys dying yet. And we'll be doing that next week, I think. So for now, let's just have one last look at the code here. And you can hear the bouncing sound at the very least. And I don't think anything else is going to happen when we touch these guys right now. Yeah, they're not actually dying because we haven't told them how to die yet. So anyway, so far so good. So I'm really happy with the way this is coming together, guys. So next week we're going to be looking at a whole bunch of the little finicky details of this game. We're going to get the interface set up so that we have a little lives icon at the bottom. We're going to have our guys turning to eggs and dying properly. We're going to do a little game over screen, and we're going to have little point markers appear over our characters' heads when we kill them, or our bad guys' heads. And we're going to make these guys spawn in the traditional Joust manner, where they kind of glow and grow out of these platforms, out of the little platforms that they're spawned in, and move up the screen from there. So lots to do still. I think we're just gonna get this done in one more long lesson, and we'll probably get it done then. All right, well, I hope you enjoyed this, and I hope you're following along nicely. Please remember to subscribe to my channel if you're enjoying this stuff. I would really like to increase my subscriber count here, and I think I'm producing some good content for you guys. In the meantime, remember to watch the Chromeworks Club, my live stream, with a little more beginner-friendly content every Saturday morning at 10 a.m. And I will see you guys with part 3 of Joust next week. Bye now.